one other kind of application that comes up with normal probability distributions is when you know the probability, you're given the probability of something, and you're trying to find a particular value of x. So you're given the probability, and you're trying to find what is x. This is 7.2, number 48. It's modified slightly from what it looks like in the book. The reading speed of 6th grade students is approximately normal with a mean speed of 125 words per minute and a standard deviation of 24 words per minute. Part A, what is the reading speed of a 6th grader whose reading speed is at the 90th percentile? We'll just call this XR. We're trying to find the reading speed at the 90th percentile. If XR is the reading speed at the 90th percentile, that means that XR is some reading speed that is greater than 90% of all other reading speeds. Here's a drawing of what that would look like. Remember that the x-axis of our curve represents different reading speeds. And XR is a reading speed. We don't know yet what XR is exactly, but we do know that it's at the 90th percentile, which means that 90% of all other reading speeds are below it. In other words, the area to the left of XR is 0.90. Also remember that the area under a curve is the same as probability. So this 0.90 is the probability that x is less than that particular reading speed, XR. There are different ways of finding out what this XR is. One way is to use a graphing calculator. On the Casio, you would use the function inv(n), which is inverse norm. On the TI calculators, you would use the function inverse norm. And when you use the calculator, one thing to keep in mind is that it'll ask for something called the area. That's referring to the area under the curve. And the calculator is always set up so that it's taking the area that's to the left of whatever x is. It always helps to draw out the curve. I'll do that again. Looking for some value XR, and we know that the area to the left of it is 0.90. On the Casio, take these steps. It will take you to the function inverse norm. It'll ask you for a tail, and you can select right or center. I would just always leave it as left. So left. For the area, that's the area to the left of XR. And that area is 0.90. So put 0.90, put in the standard deviation, put in the mean. On the TI calculator, you'll use inverse norm. And when you use that, the first thing you put in is the area, but keep in mind that it's the area to the left. So still putting in 0.90, then you put the mean and the standard deviation. And your result should come out to 155.75 words per minute. Another way to solve this problem is to use the probability table. Draw the curve. Since we know that this represents the probability that x is less than this reading speed xr, and it's 0.90, that means that we can go to table 5 and look for a value of 0.90. And to look for it, we'll look in the middle, because that 0.90 represents an area, and ultimately what you'll need is the z-score. So in the middle, we'll look for the value that's closest to 0.90. It looks like the closest one is 0.8997. And the z-score for that is 1.28. That'll be helpful to know, because knowing the z-score is 1.28, you can use the z-score formula, plug that in, plug in the mean and standard deviation, and then solve for x. So here's the z-score formula. We know the z is 1.28. Here's the mean, the standard deviation. We've got to solve for x. Multiply by 24 on both sides. Add 125 to both sides. The result is 155.72 words per minute. Pretty close to the result from the calculator, with just a slight difference. In the next video, we'll look at part B.